So I've posted out the link on social media, so we'll see how things go. I'm gonna go to M15 as the first target. I got a target list. M15, M2, M1, M1, M31, 32, and so on and so forth. So I'll just meander through those targets and see how things go. So I'll start with M15. This way on the telescope here. And I will get this exposing there. All right. So we're slowing the telescope. So that'll so we will be looking at M15 here in a moment. We have to wait for the telescope to get pointed that way. So what you're seeing on the screen is stars whipping by the telescope as the camera takes pictures as we telescope slews. What we're doing is we're aligning to a star that's near the object, and then once we're aligned with that, so we can now slew to the object. Okay, so there's M15. Now let's make it a little easier to see. So what we're going to do is we're going to change our exposure up here to 10 seconds and take a picture. So it's going to take 10 seconds to take the picture because we have to collect all the light from M15. And there it is. Well, there's M15, a globular cluster. Let's do a little bit more exposure. I'll do 20 seconds, and then we can zoom in a bit. So as you can see, M15 is a globular cluster. And let's stretch a little different here. Here we go. So this is what's known as a globular cluster. And we just had there we go, 20-second one. And it's basically a big ball of stars orbiting our galaxy. See if I can do the screen switch a little. There we can see more detail in the center stars here. We have a thing over here called screen stretch, and that's the digitizer on the camera is 12 bits, but the screen is only 8 bits, so we have to squish 12 bits into 8 bits, and that's what the screen stretch is all about. If you have any questions in the chat on YouTube here, you can type them in, and I will answer them as I see them go by. Actually see the questions go, anything go by over here on the side, so I can see them as well. And if there's an object you want to look at, let me know. If it's up, we can try to point at it as well. I have a list of objects to look at. But, I don't have a specific goal other than to show people some sky tonight. All the images will be monochrome because, of course, my camera is monochrome, and we're not going to be doing 3-color imaging tonight. 3-filter imaging, just looking at stuff. So, see, there's some extra people popped in. What we're looking at is M15. It's a globular cluster in the constellation Perseus. It's a big ball of stars orbiting our galaxy. And here we'll take a slightly longer exposure. We'll take a 30-second exposure of it this time. See what it looks like. So as you can see, the camera is now taking a picture. We'll expose for 30 seconds and then we'll download it and take a look. Let's rearrange things a little bit here, make things a little easier to see. Ooh! Yeah, we've got to change the screen stretch on that, obviously. The night background is coming through. There we go. I am in the backyard of my house, so there's a bit of light pollution, which makes it a little trickier to do things like this. But here we are. We can see how large this cluster is just looking at this here, because you can see the stars go from about here to here faintly, and that's just the bright core in there. There's the whole frame. The whole frame from corner to corner is about the size of the full moon. So if you picture that in your head, that's how big this frame is. So it's a fairly substantive object in the night sky. Easily found in binoculars. And quite pretty to look at. Quite popular with the amateur crowd. So what do I have on next on my list? Another globular cluster, M2. Okay, why don't we take a look at that? So what I'll do is I will change this to 1 second exposure, but I'm going to change this here where it's a single to focus. And it's just going to take a picture every second automatically while I go to the telescope and move things around. So let's see, enter Messi 002. So what the telescope's doing right now is it's got its own little computer and it's searching through its database and it's finding a star that's close by, because we can use that star to more precisely aim the telescope. And that's what we're doing now. And let's change the screen stretch so you can see things. There we go. Just a moment while I go and point the telescope. We won't be looking at M2 because it's behind a tree. So we'll move on to our next object, M31, the Andromeda Galaxy. That'll be, should be easy to find. M31. Telescope will slew. We'll probably actually start seeing stars in a moment because, there we go, because we popped out from behind the tree. And I'm going to go back to the telescope here to get everything pointed. Okay, and there we are at M31, Andromeda Galaxy. Let me just stop this. And what we're going to do is we're going to pump the exposure time up to about 30 seconds here, which will give us a much nicer view. There we go. So we're just waiting. It'll be another 10 seconds. You can actually see how long it takes by looking here where it says exposing light. This number here changes with the amount of time it's taking. And there we go. It's the Andromeda Galaxy, or at least part of it. It's actually quite large. It extends well beyond the frame both ways. This is kind of the central core of it. See a little bit of a dust lane here. I'll bump this up another 10 seconds. Oops, we were doing here, stop. There we go. Doing it on focus. Hi Simon, I'm in a big parka. So we'll do 40. There we go. We'll try that. So we'll do a 40-second thing and see if we can. If we're going to get much more detail. I can't really do much longer of exposure here because of the fact that I'm in the city, but it will. But we'll see if we can see a little bit more. This is the next. It's not the closest galaxy to us, but it's the next closest. It's the closest galaxy to us that's large and looks like our galaxy. So it's the So that's what's kind of cool about it. It's also, there we go. It's rushing towards us. So in about 4.5, 5 billion years, it and our galaxy will collide and merge, form an even bigger galaxy. So here we have more. Here we have it again. You can see some more of the dust lanes inside the galaxy. These are the dust inside inside spiral galaxies are things that where stars get born and all that. So there. So here, what I'm going to do now is I'm going to get the telescope to point to a companion galaxy of this, called M110. I see RSC Calgary's popping in some trivia here. And we're looking at Andromeda, which is about 2 million light years away. So the light we're seeing this by left there about 2 million years ago, a little over 2 million years ago. It's been traveling a long time, and it's over 100,000 light years across. So the stuff on the near side, which will be this side here with the dust lanes, is 100,000 years younger than the light that we get from this side that we're seeing with right now. So let's, while you're looking at that, I'm going to re-aim the telescope to M110, which is a companion galaxy of M31. So I'm going to need to take over the pictures here. Oh, yeah, M15. Yeah, it's in Pegasus. I goofed. I'm going to blame the cold air. So I'm just going to go to focus mode here for a second so I can get the guide the alignment star centered. Way too much. Change the motor speed a little bit on the telescope so it doesn't slew as fast. There we go. This is actually the star Merak. The telescope's using it to figure out exactly where in the sky it's pointing, so it can point more precisely to the target, which is Messier 110. Okay, now it doesn't look like there's much there. That's because we only have a 1 second exposure. So I'm going to stop that, and we're going to do a 30-second exposure. And let's make sure that's only on single. Also get lots of 30-second exposures. So that do its business. So you can kind of faintly see something in the middle there. If I play with the screen stretch, maybe we'll see a little bit more of it. But yeah, it's kind of a faint blobby thing there. That's the that's our target, Messier 110, which is an elliptical galaxy that orbits Messier 31 and the Andromeda Galaxy. It's a satellite. There we are. It's Messier 110. It's a satellite of the Andromeda Galaxy. It's an elliptical galaxy. Let me see if we can. What we'll do is we'll go for 50 seconds and see if we can get a little bit better here. Yeah, we'll go 50 seconds, see what happens. So what we're looking at right now is Messier 110. It's a galaxy that's orbiting the Andromeda Galaxy, so it's also about a little over 2 million light years away. But it's considerably smaller. It's a very small satellite galaxy of M31. Just waiting another 20 seconds here to get a more deeper image. It would kind of be like that. I was just have somebody just in the chat saying if we were in Andromeda, would this be like looking back at the Milky Way and seeing the Large Magellanic and Small Magellanic clouds? And it'd be something similar. I know it wouldn't look exactly the same, of course, but we'd see something similar. We'd see a large spiral galaxy, which would be the Milky Way, and then a bunch of smaller satellite galaxies. Now, it's about as good as it's going to get, given our time constraints and the fact that like I said, I'm in the middle of the city, so the amount of stretching I can do to make this look better is kind of limited by the background sky. But this is Messier 110. I don't think it has a formal name. The Messier numbers, by the way, that I'm quoting are from a catalog of objects created back in the 1700s by a French comet hunter by the name of Charles Messier. He was quite into finding comets because, of course, you get fame and not necessarily fortune for finding them. He actually found 19 comets. He was actually quite prolific at it. But he found a bunch of non-comet fuzzy things in the sky And so he just made a list of them so they wouldn't accidentally mistake that. And this is one of those things. There's no order to it. Like this is M110, 110th object on his list, and it's beside M31. So now the other thing I'm going to slew to now is M32, which is another satellite of M31. So if you give me a moment, I will make that happen. I don't want to spend too much time here because it's pretty close to the zenith and it's frosty and the mirrors all frost up and won't be able to see anything else, but that's winter for you. I have to go over and look through the guide scope to make sure the star we're going to use is centered, so that's why I disappear every now and then when we're changing. So we'll go back to focus here. I didn't realize it had a bar too. There we go. Now we just need to get that centered. Go right to it the other way. You can see kind of the cool streaks that makes as the camera takes the exposure and the telescope moves. There we go. Now the telescope knows where it is. We'll tell it to go to M32. And let's make that 20 seconds. So while we're waiting, M32 is a satellite of M31. Large galaxies tend to collect other galaxies, so they do have satellites. The M32 is the one that it's quite visible. It was apparently more visible than M110 because Messier got to it before 110 did. There we go. And there's M32, M31. We're actually, if we made this exposure longer and we were in a darker site, we could actually see part of M31 kind of in this area here. But actually, that might be part of it over there. So this is another satellite galaxy of M31. So I'm just taking a look at my list of targets that I had drawn up, and okay, I've got an interesting thing in a sense. It's a double star, but it ended up on a list of deep sky objects that generally don't include such things. So it would have been a mistake at that point. NGC 272. NGC is another catalog called short for New General Catalog. It was made back in the 1800s. For a bunch of deep sky objects like galaxies and clusters and stuff. So we're going to go find it. So I want NGC 272. Telescope, look for that. These modern telescopes are great. They go and find things for you. It's wonderful. So what we're doing is just aiming over to NGC 272, which, according to the catalog at least, was a double star, which is kind of interesting. Our star isn't a double star, but most stars are in pairs. So this would be, now I'm not sure if this is an actual binary star where the stars are orbiting. Now this isn't it, of course. This is just us getting ready to point to it. This is the star Merak again. I'm going the wrong way again. The telescope has a mirror. My slow motion controls, east and west, are set right on my computer screen, but north and south are flipped. There. So now we're going to slew to this NGC 272, which we should be there. Okay, let's increase our exposure up to 10 seconds here and see what we can see. I've never actually seen this object before, so this will be kind of fun. M35, let's see. It is. I have it later down on the list. There we go. There's nice two double stars in the middle there. That's probably it. Stop focusing here. Single. Let's go 15 seconds. There we go. And I'll probably give us a nicer picture here. And we'll go look at, actually, we've got next thing on my list is Mars. There's Mars. There's Mars. You can see Mars just fine. So there we go. It's a double star, and since it should be in the center, so it's probably, I would imagine it would be these two here. I'd have to break out a star chart to see for sure. So, well, let me go look at Mars for a moment. Let's go hunt down Mars. So let's put this back to 1 second. And I'm going to get this going to Mars. I'll just go solar system Mars, it's faster. Also, this means my mirror and all right. We should be on Mars now. So let's just take a single 1 second exposure and take a look and see how close we are to Mars. There's Mars. So it's hopelessly overexposed at 1 second here. So let's go down to 1/10 of a second and see if that helps a lot. Nope. Let's do this also to planet. I don't think we're going to get much of a better picture of Mars. The issue being that we're almost See if it says max pixel. We're almost at the top end of the Imager's thing here. So let's see if we can try 1/100th of a second here. Let's try 1,000th of a second. There we go. That's probably better. Now it's kind of tiny, so let's take a look at it. My telescope's quite this particular telescope mine's quite wide field, so it doesn't necessarily do the. I do have Uranus on the list. I'm going to go to M33 next, and then nip over to Uranus. But there's Mars. Doesn't look red because my the camera I have on this currently on the telescope doesn't do color pictures unless you do multiple filters. So it would take. I'm just going to put this on focus, and it can continually cycle on Mars there. Like you'll see it kind of dance around a little bit, and that's because, of course, of the seeing. That's the air moving around. It's one of the reasons why it's very hard to get good, clear pictures of planets. At least taking only one image. So there's Mars. While you're looking at Mars here, I'm going to get things set up to move to Messier 33. So the Triangulum galaxy. It's another spiral galaxy. It's another companion. Well, it's not a companion to our galaxy, but it's the other large. There's 3 large spiral galaxies in the local group of galaxies: M31, the Milky Way, and M33. So it's the next. It's the next closest large galaxy to after Andromeda. I just need to find the right button, press the right buttons. There we go. 033. Okay, so Mars is going to disappear here in a moment because I'm going to slew the telescope to M33. I'm just going to make this small enough so I can see everything. And we'll take the screen stretch here and turn that back to low. And let's stop this for a second and make this 1 second so we can see stars again. Planets are quite bright, so we don't have to do huge exposures on them, but stars are considerably fainter. I'm just going to go head over to the telescope. I think that's the right one, but I just want to make sure by looking through there's a smaller auxiliary telescope attached to the telescope, so I look through that. That's the correct star now. I don't know, I've never tried. I haven't done a lot of imaging of 110. Project for some point in the future. Okay, so we should be flipping over to M33. Now, M33 is a little fainter from our point of view, but that's mostly because we're looking at through more of our galaxy at it, so there's a lot more dust. So I'm going to make this a 30-second shot. See what we get. So stop. Let's take it out of focus. There we are. If anybody has any questions, feel free to pop them into chat. You see, there's a couple of people from the Calgary Center of the RISC online as well, so if I don't notice your question, they might. Okay, so somebody will answer it. So there we can see a little bit of it. It's kind of more face on than Andromeda. I'm gonna do a trick. Now right now you see here it says light 1 by 1. What I'm gonna do is I'm gonna lose some of the resolution, but by binning 2 by 2, I'm gonna take 2 pixels to make them 4. So it gives me a lot more ability to see. So we'll be able to get a better view of it. But this is Messier 33. It's in the constellation Triangulum. It's the other large spiral the third large spiral galaxy in our local group of galaxies. So in a moment, about 5 seconds or so here, the image will get smaller. I'll just zoom it up again. There. But in 30 seconds, we've got the same exposure as about a minute. Let's change the screen stretch a bit there. Can't do too much more screen stretch because of the background light from the city. I'm going to try doing some of this here. No. Whoa, wrong way. M33 is a trickier target because since we're looking through more of the dust of our own galaxy, it's a little dimmer, but you can see one of its spiral arms here. This is actually a star forming region in the galaxy. If we were to take a color image, this here area here would actually be kind of reddish pink. Any of these individual stars, they're all what we call foreground stars. They're stars in our own galaxy between us and it, and there's more dust towards this than there's towards Andromeda. If there were no dust in our galaxy, this would actually be brighter than Andromeda. We're seeing it almost face on. But it's especially from a suburban sky, it's a very difficult target. As you can see, I can increase. I'll go another 10 seconds here, and we'll do another image and see what we get. But so we're just waiting for a 40-second exposure, which, because this is binned 2 by 2, is the equivalent of see, so I'm getting 4 times the light, so 40 seconds would be 116 seconds. So yeah, 160 seconds. Sorry, apparently I shouldn't do math this late this late in the evening. So just another 5 seconds here. And it's washed out because we have the screen stretch for something else. There we go. So it's we can see it's a little bit more, we get a little bit more detail of it there. So you can see if that spiral arm's a little bit more defined. Another one kind of coming up here. A lot of this glowy stuff is also part of the galaxy. Because we can't do too long of an exposure. What we not normally would do is we would take a lot of short exposures and stack them together, and we'd get a much better view. But this the moment, this is where it's going to be for now. And so while we're looking at this, I'm going to check my next target is Uranus. So I'm going to hunt down Uranus here while you're looking at that. And this I'm going to use a guide star for because it's a lot harder to see. So we're slewing the telescope to a brighter star that's nearby. I'm just going to do this and change this back to 1 by 1. And then we're going to put this on focus. And this on 1 second. And expose. And then we should see a star. Okay, I'm just going to go, well, so we'll move this over a little bit and see if that's, and I'm going to go check the auxiliary telescope that's on the mount. There's two telescopes on the telescope mount here in my backyard right now. One's the big 8-inch Newtonian telescope that you're seeing the images through. That's the imager's hooked up to. But there's a smaller refracting telescope, about 80 millimeters. Normally it's used for guiding in that, but I can also use it if I have it lined up properly, which I have it tonight, to see what the big telescope's seeing, though admittedly not as bright. Just give me a moment here. That is it's definitely our star. I'm going to hit enter, and we should flew to Uranus. 6th planet in the solar system. And there it is. So this here is actually the planet Uranus. We'll zoom in. And if this were a color imager, it would have kind of a light blue hue to it. And let's go with the 2-second exposure here. We'll just let it run. See, 2 seconds might be too much. There's the planet Uranus. Yeah, it's gonna yes. The spikes you see coming off of it, by the way, here and here, are actually an imaging artifact. The telescope that the camera is attached to is a Newtonian telescope. So it was developed by Isaac Newton 400 years ago. Not this particular telescope, but the design. So there's a big mirror at the back of the telescope that collects the light. The light gets bounced forward, and there's a little flat mirror that directs the light 90 degrees to the direction of the light coming into the telescope and out the side. And something has to hold that little secondary mirror in the middle of the telescope somehow. And there's 4 little metal kind of veins that do that. We call it a spider. And what they're seeing there is the diffraction spikes around that. So there's planet Uranus. Next target I have on my list here to look at is M77, which is a galaxy of some kind. We'll get ready to go there. Just here. I'm going to head to M77 now. So I'm going to disappear and go around. Sweet. Oops, going the wrong way. There. And we've flipped across the meridian, so the telescope's taking a bit longer to flew than it normally would. The mount is a German equatorial, so it, depending on which side of the sky you're on, it has to flip the telescope around. Okay. All right, so I'm just going to go check the auxiliary telescope here to see if that's the right star. There we go, that's the right one. Let's get that centered. get close to center. And the telescope will slew over to M77. There we go. So that's kind of faint. It's right there, so 2 seconds isn't enough. So let's do a 20-second exposure and see what we can see. We'll take it out of focus too. There we go. Tell you more about it when we get a better picture. But this is another one of those objects on Messier's list of fuzzy objects. My notes, I have it as a galaxy. Oh, there we go. There it is. I think it's a spiral galaxy right there in the middle. Zoom in a bit. So what we'll do is we'll do that binning trick again. You can see a central bulge here. And you can see kind of the spiral arms around it there. There we go. Do a 30-second, so we'll do 40 seconds to see what we get. That's too much. Anyway. So this is a spiral galaxy. I'd have to go look up some more details about it. Like its distance and that. It's considerably greater distance than M33 and 31, obviously, since it appears much smaller in the sky. Most spiral galaxies are roughly the same size, so I mean there are size differences. They're not exactly the same, but so if you see two spiral galaxies and one is much smaller than the other, the smaller one is just much farther away for the most part. And there we go. That's probably about as good as we're going to get. But there we go, another galaxy. This one's probably on the order of about 25 to 35 million light years away. I would, if I were to hazard a guess, based on its size. And yeah, so we can put it back into a little bit more context here. We'll zoom out a bit. So there it is there. So this is the size of the full moon. So it's a very, from our point of view, a very tiny object. It's probably quite large in the real world, given that it is a galaxy and it is a spiral galaxy, so it's a galaxy like ours. So it'll, but it's much farther away than the two large spiral galaxies we looked at earlier. So let's move on. NGC 752, an open cluster. So an open cluster of stars was our next target. So let me get ready to go for that. So to do that, I'm going to make that smaller. Change that to 1 by 1. That, 1 second. And then focus. If anybody has questions, feel free to pop them into the chat. I can see the chat, so I can always answer questions there. Just there's about a 20-second delay from when I say something to the time it goes out into the world, so let's keep that in mind. Let's see. So I want to go somewhere else. Go to database NGC. NGC 0752. And telescope's looking for it. There we go. So it's now going to go find a bright star near that object. Apparently it's either it's on the other side of the meridian or it's in the northern sky. Telescope's doing a fair bit of slewing actually. we're just pointing to another object. Oh, it's near the meridian. Oh, it's near the zenith, actually, so it's almost straight up. Okay, so let's get that star centered. And we can going the wrong way again. And a little bit more. There we go. That should do it. Now we're going to move off to the target. And so this is an open cluster, so I don't know. So I don't know how large it is because it's not one I've looked at before. But let's go with 15 seconds because things tend to be fairly bright. And single. And an open cluster is just a cluster of stars. And what's special about these is that the stars in an open cluster are all formed roughly at the same time, and so they're slowly moving out into the galaxy. There we go. This is a very sparse open cluster, but this is likely it here. And as a cluster, the stars would have been born roughly the same time in the same nebula, and they've moved out of the nebula now, and they're moving off into space to drift off into space and then just become individual stars. Our own sun would have been in an open cluster at some point. Open clusters are very, very important in astronomy, mainly because since they were all formed roughly at the same time, astronomically speaking, I mean, they're several million years apart, but in the lives of stars, that's a very short period of time. We can use them as a natural laboratory to, kind of figure out how stars are born and evolve and how they die. The next object is also a open cluster, so we move there. NGC. Oh, no, M45. Ah, there we go. Messier 45s, the Pleiades. Pleiades is a naked eye open cluster, so if you're able to go out, you could actually go and try to find it. It's fairly bright, though it's hard to see even in the city. Let's see, I can just kind of faintly see it here in my backyard without just looking up. Mind you, I've been staring at a computer screen, which probably isn't helping my night vision. Again, if anyone has any questions, please feel free to ask. So we're now moving the telescope here. Why don't we just do this? Over to the Pleiades. Ironically, the bright star the telescope has selected to guide us to Pleiades is actually in the Pleiades. Yeah, there is a weird kind of, if you drop out and drop back in, it starts playing it. It assumes you don't want to pick up from where you left off. So you have to kind of take the little scrubby thing and scrub it to the end. I found that out when I popped out to look at social media briefly. It's kind of annoying with the YouTube app. Anyway, so we're slewing over to M45 here, which is, just tell it to center it. M45 is a fairly large open cluster. Like I said, it's very bright, very easy to see with the unaided eye, and it it's way larger than what the telescope's field of view is. I'm just going to do a 30-second exposure here. Some some of the stars in this cluster do have some nebulosity around them. Now, the nebulosity is not the nebula that it was formed in, but a nebula that the cluster seems to be running into. It's in a, and it's when it, if you are looking at it, yeah, that's kind of a funny thing about the YouTube thing. Just if you're looking in for people wondering what I'm talking about, there, if you look into the chat, I'm chatting with someone about how sometimes if you drop out of the YouTube app and come back in, it puts you kind of where you left off as opposed to where we are now. So here we are in the here we've got a picture of the Pleiades. You can see some of the nebulosity down here. Let me maybe if I increase the screen stretch a bit. Yeah, you can kind of see some of it in here. I'll do a 40-second exposure. Oh, we're in focus mode. Stop. There we go. Now single 40 expose. We'll get maybe a little bit of the see a little bit of the nebulosity. It would appear blue in a color image because it's a reflection nebula. The gas and dust the stars happen to be running into. They're not. The stars aren't exciting the gas, or at least that we can tell. And what's happening is we're seeing reflected light from that nebula, and because the size of the particles in the nebula preferentially scatter the blue light, we see the blue light coming back towards us, whereas the redder light, so the greens, yellows, and reds, go sailing through the nebula out the other side. Kind of the same reason why the sky is blue, by the way. There we are. So there's some nebulosity around this star here. And that's part of the nebula that this cluster is running through. Again, the spikes you see coming off the brighter stars are an artifact of the telescope. It's just the supports for the secondary mirror and the light's diffracting around those. Again, if anyone has any questions, feel free to pop them into the chat and we'll answer them for you. Next up is I think I'm just going to take a look and make sure I've got a line of sight to it. Yep, I do. So the next thing we're going to look at is M42 and M43, which is the Great Nebula in Orion. Very, very pretty, very, very bright, and very easy to find. Even if you're in a dark site, you can see it naked eye, and if not, a pair of binoculars will do it for you. So we're just going to go heading over there. Oops, I'm not hitting the right buttons. There we go. And we're going to turn that over to 1. And this to focus. No focus. There we go. No, focus. I want to focus. There we are. So we'll get the telescope aimed that direction. Okay, I'm going to have to go peek through the auxiliary telescope here to get things lined up. And then we'll slew right on over. There she is, in all her glory. Let's get it centered a little better. Oops, I'm going the wrong way. Hey, let's go this way. There we go. This car just backfired. Let's go here. Let's do do a 15-second exposure. Oh, too far. 15. Let's type it in. There we go. And we can. Now this is a difficult thing to photograph because the center region here, which we can see not bad right now, is very bright compared to the outer regions. There's much more to this that we're not seeing. And the dynamic range of most cameras isn't good enough to show it. There we go. So we often can see the middle or the outsides, but not both. So you can see that this does extend a great deal out the sides. Go back to here. Now this bit up here is M43, and then this bit down here is M42. There are actually the part of the same cluster of gas. There's just a dark band of gas here that makes them look like they're not attached. Let's go to 30 seconds here. See what we can see if we can get some of the fainter bits around the edges. Yeah, let's see what time it is. Oh, 8 o'clock. Once we're done looking at this, we'll look at another open cluster. We'll look at another nebula, and then we'll look at a supernova remnant. And we'll do that as a calling that a night for tonight. So there we go. We have a much. So let's see if we can get some more detail out of this by playing with the stretch. So we can come here and we can do this and get a lot of the detail in the center here. There's some stars here. I'll zoom in. See these stars here, the trapezium. They're very, very young, hot stars that are in the center of the nebula, causing a lot of this stuff to glow. Not all of it, of course. This is tens of light years across, hundreds of light years across. And then we can do a little bit of this, and then bring this down like this. Now the center is way overexposed, but now we can see all the detail on the gas coming out way out onto the sides of this. We can see some detail in here. And we can make that even more. I think that's about as good as we're going to get with what we got. But you can see all the knots and various things in the outer, dimmer bits of this wonderfully photogenic nebula. Getting a really good picture of this is tricky, because to get both of them, you either have to do a lot of short exposures and stack them together, and then do some fancy high my brain just froze up. High dynamic range, an HDR type of photograph image. So we'll move on to, let's see, the open cluster M34. Oh, there it is. Find where I put my telescope controller. We're slewing to another open cluster here, M34. First, we have to get onto our alignment star. There it is. Just going to double check by looking through the auxiliary scope. That is it. Now, interesting thing about this particular star, let's get her centered. And before we move on to the next target, is that this star is Algol. I'm going the wrong way. And it's a variable star. So it actually varies its brightness over a period of time. memory serves, it's an eclipsing binary. It's actually two very close stars, and one's dimmer than the other. When it passes in front of it, the light of this star, the apparent brightness gets dimmer and dimmer, which is kind of cool. It doesn't do it in a period of time that we'll notice tonight, but this is something interesting to remember, that not all stars shine equally brightly all the time. We're going to zip over to M34. Apparently it's right on the meridian, so the telescope's going to flip from one side to the other. Just a function of the type of mount the telescope has, which is a German equatorial. There we go. It should be there. Oh, almost on it. It's up in the upper left there, so let's see if we can get it centered. There we go. It's kind of centered now. So let's stop this focusing bit and let's take a 15-second shot of this and see what we can see. This is another open cluster. So it's another group of young stars because they haven't spread out yet. They're all born roughly the same time. There we go. That's a much better picture. We'll wrap this up to 30 seconds while I yak, and then what we'll get is fainter and fainter stars that are members of the cluster. But so then put that down. So I don't actually bump something on it. Come on. There we go. So these will be all stars that are. Whoops. I think Roland, if can probably find out how old it is by looking it up online. I can't do that where I'm because I don't have anything to do that on. But they'll be young stars, less than 1 billion years old, probably only a couple of 100 million years old. There we go. That's much better. You can see the cluster. Oops, cluster over in here. Once we get out here, these stars here are probably either foreground or background stars, but most of these stars here will be members of the cluster. Though that is one of the tricky things when you're studying clusters, is to make sure all the stars that you're seeing are actually the clusters that the stars that are members of the cluster. Some of these stars will be between us and the cluster, some will be on the other side. So one of the things they do is they they take spectra of all these stars, and they check the radial velocities. In other words, the velocities of them coming towards us or away from us. The cluster members will have similar radial velocities. They want things that'll be different won't be. So there we go. We've got an estimated age of about 200 and 250 million years. So these are very young stars. We also look at the proper motion, which is the motion across our line of sight. The cluster members tend to have similar proper motion and radial motion, whereas the farther out ones will tend to have different ones. This is one of the ways we kind of differentiate between the two. So here we have another lovely open cluster. Got two more things that we'll look at tonight. We'll look at M78, is a nebula. We'll move there next. Get the telescope set up to do that. And 07. Like I said, modern telescopes are great. Just type in what you want and they go look for it. Back before the computerized telescope, we'd have to use a star chart find a bright star nearby. It's kind of what we're doing tonight, because we're having the telescope find a bright star near the object, and then using that to tell the telescope that it's in the right spot, and then it hops to the right place. Well, we used to find a bright star, point the telescope at it, and then looking at a star chart, find a bunch of stars that kind of led the way to where we wanted to go. Well, kind of the same thing, except that now the telescope's doing all the work. There we go. Now this is the star Alnitak, which is in one of the belt stars of Orion. Get her all centered here. Wrong button. There we go. Let's check, see if that's the right way there. Oh. There. Now, I'm just going to check something here. I'm going to stop this for a second. And we're going to do some hideous exposing on this bright star. I'm only going to do 20 seconds though, because if it's too bright, it'll crash things. But oops, I don't want to focus. Stop. If this is the star I'm thinking of, there might be a nebula right beside it, but it'll be hard to see. So we'll do a 20-second exposure, which will hideously overexpose the star, but it should bring out, if that nebula, the nebula I think is there, should bring that out. Then we'll head out to M78. The telescope's computer patiently waits for us to do that. So let's see here. Yes, there it is. Some nebulosity up here, and the Flame Nebula here. And if you come down this way, we can't see it in this image, it'll be down here somewhere, is the Horsehead Nebula, which is very difficult to take pictures of, so we much darker sight. But this is kind of a cool nebula. Maybe we'll come back to that once we're done looking at M78. So why don't we head over to M78. Okay, so we're not seeing anything because it's not a long enough exposure. The nebula will be in here. So let's get our exposure up to 20 seconds here. And let's make that single. So we'll have 20 seconds, we'll have a take a look. As Roland's pointed out in the live chat, M78 is a reflection nebula. Apparently it's 1,350 light years away. So the light we see it by left 1,350 years ago. A light year is a measure of distance, by the way, not a unit of time. 1 light year is roughly 10 trillion kilometers. There we go. There's our nebula. Right there. Now we have something to look at. I can increase the exposure up to 40 seconds and we'll get a better view. I'll make this medium. So we're seeing, reason why we see it is the light from these stars here is bouncing off of it and coming at us. So if we were to take a color picture of this, it would appear blue. Nebula color has a lot to do, there's a lot of things that affect the nebula color, but generally, if it's kind of a sky blue color, it's a reflection nebula. If it's kind of a red color, it'll be an emission nebula. There's dark nebula, which are black, which when we nip down and take a look at the Flame Nebula there, I'll on our way back. Now, Roland's popped up that it's kind of close to the same distance as the Orion Nebula. Most of the nebulosity in Orion is all part of what's called the Orion complex, and most of the constellation Orion is one big, huge gas cloud, really. So here we have a much better view. For 40 seconds, I'm not going to put the screen. Yeah, that's not going to help at all. So there we go. There's M78, which is a reflection nebula in Orion. And what we'll do is, while we're looking at that, we'll pop back to meet that. Stars. Back. There we go. The downside of computerized telescope is that it's sometimes if you're wanting to point at a bright star, it's actually a bit of a pain in the butt because you have to look it up in the. Actually, it does kind of look like this. Roland's mentioned that the famed Deep Sky Observer Father Lucian Kemble used to call it the Spook Nebula because it kind of looked like a ghost. You can kind of see that. Got the two eyes there, and then the ghost trailing off. So we're just going to. What I'm going to do is flip us back to focus here, and we'll take a quick look at that nebula, flame nebula there. I just want to get us into the get us into the neighborhood. Okay, so we should just have to do this. And we'll get that skewered off the side this way. That should do it. So what we'll do is we're going to, now it doesn't look like there's anything here, but what we'll do is won't bin it. It makes too bright, but we'll make it 30 seconds. And single. My goal is to see enough of it so I can pop that star out of the field. I've tried to go deep on this before with that star in the field. It actually tends to crash the computer because the star is so bright compared to what we're looking at. It messes up the software. This wasn't actually going to be on the program initially, but since we're here anyway, might as well look at it. There we are. You can see faintly right here. So I'm going to move that star so that it's off the field just over here. So let me put this back to focus in 1 second. Actually, we'll make it half a second. And then we can move that out of the way. Just get it off the frame so it's not causing problems. There we go. And now let's make this 40 seconds. And let's do our binning trick. Oh, wait, I don't know how to say if I'm a single. There we go. This should give us a bit of a view of what's called the Flame Nebula. It's another nebula in Orion. Should show up roughly in this area here. Once we're done exposing, actually. zoom in because it's going to get smaller. Got another 10 seconds of exposure left. And there it is. A lot of this down here is, I mean, we're still catching a little bit of that star, but now you can see that nebula that's beside that star there. It's a brilliant red color when it's in color. Let's see if I can adjust things to make it looking a little better. No, there. It's actually quite a impressive little nebula to see when you can properly expose it without that other that star in the way. It just tends to saturate the imager out, so it causes some problems sometimes. So while you're looking at the Flame Nebula there, we'll go to our last target for the night. The first object on Charles Messier's list, Messier 1, which is a supernova remnant. It's what's left of a star that blew up. So let me change this to focusing again. We'll make that one. We'll make that, and then focus, and make this smaller. That way I can get our alignment star all good to go. Let's take this off of manual too. Put it on low. And we should, no, low, not manual. There we go. And let's get it lined up in the middle here. And now we'll slew over to Messier 1. Otherwise, sometimes often called the Crab Nebula. Because apparently the Earl of Rosse, who named it the Crab Nebula, hit the wine a bit the night he was at the telescope, because I've never actually seen it look like a crab. So let's increase our integration or exposure time here to 20 seconds so we can see things. So this is, once we get a picture of it, this is Messier 1, the Crab Nebula. It's a supernova remnant. So it's the remnant of a star that blew itself up back in 1054-ish. There are records. There we are. You can start seeing it right there. Right there. So we'll bump our integration time up to 40 seconds here. Well, the Roland's popped up. It's about 6,500 light years distance, so it's relatively close, especially for something that blew up. So it's a quite often studied nebula. We've got pictures of it going back enough that we can actually measure its expansion rate, which is kind of cool. Yeah, torture undergraduate astronomy students with it all the time, doing that measurement. Let's see if we get a little better of an image there. Problem is I think we have a little bit of haze, which isn't helping. But there's the Crab Nebula there. It's like I said, a supernova remnant. It's what's left of a star that blew up. Stars that are 8 times the size, 8 times the mass of the sun or bigger end their lives quite spectacularly in that they blow up in what's called a supernova explosion. When these stars blow up, they're brighter than the galaxy that they're actually in. We can spot supernova in other galaxies quite easily when they happen. They, like I said, they signify the death of a star. And then what's left behind is what's called a supernova remnant. This is the gas and dust that once formed the star that's been blown off into space. Rollins poked in that the initial detailed sketch showed some of the synchrotron radiation and not the hydrogen, so it looks a bit like a single crab claw in this sketch. Like I said, sometimes there's creative license in when people see these things. Ironically, astronomers are always often blamed for not being particularly creative in naming stuff, so we'll take what we can. So there, this is think about as good as it's going to get. We can do our spinning trick and see if it makes it any better. And we'll do another 40-second exposure, and then we'll call it a night. Just about done the exposure here, another 2 seconds or so. And that's going to be hugely overexposed. So let's go there. Oh, that's a little better. That shows it much better there. The equivalent of a 160-second exposure in 40 seconds. We lose a little bit of detail, but it's easier to see. So that's the Crab Nebula, M1, a star that blew up a long time ago. It's like I said, we've actually discovered the star. Well, we don't know the exact star it blew up, but we know when it blew up because the Chinese astronomers kept very good records of such things. And in this location in the sky in around 1054, they noticed what they called a guest star. So a star suddenly appeared, was bright enough to see in the daytime. You could read by it at night, and then it dimmed away into obscurity, mainly because it had blown up and left this behind. The supernovae are important in that every element heavier than iron are made in supernova explosions. So if you look at a periodic table, inside stars you can make up to iron. It's kind of the way that nuclear physics works. Once you get to iron, that's it. You can't make anything heavier than iron in a star. The temperatures in the star aren't hot enough. So to make anything heavier than iron, so gold and stuff like that, and uranium and whatever, you need a star to blow up. And that's when the star blows up, all these heavier elements get created because there's a lot of energy in there. And you also get these, and then that gets spread out into space thanks to these nebula. And eventually this nebula the gas and dust in this nebula will meet up with other gas and dust from other nebulas and form a larger nebula, and then gravity will cause contraction and we'll get a new star. So I think that's going to be it for this evening. It's nearly 8:30. We've gone down more or less down the list I had. So if you have any questions, please feel free to add in the chat, or you can hit me up on social media. And I'll try this. We'll try this again maybe next month. So with that, I bid you all a good night.